In this example, we want to show that the given identity is not an inner product. So remember that there's a couple of things that we want to show. First, if something is an inner product, then the inner product of V with itself should be greater than or equal to 0, and that the inner product of V with itself equals 0 if and only if V is 0. So now, if we think about that, property, so our x1 and our y1 are the same, our x2 and our y2 are the same because we're taking the inner product of V with itself. And so x1, y1 would end up here. Okay, so we get the absolute value of whatever that is, plus the absolute value of x2, y2. So those guys end up there. And if x1 and y1 are the same, this is either 0 or it's greater than 0. And if these two are the same, this is either 0 or greater than 0. And the only way that it's 0 is if this inner product is 0 only if this and this are both 0, which means x1 is 0 and x2 is 0. So this first property is satisfied. Okay, next. The inner product of V and W is equal to, in this case, we're talking about real inner products. So the inner product of V and W is the inner product of W and V. Well, again, if you look at this, if you switch the role of X and Y, it doesn't switch the role of the inner product. So this one is also satisfied. So our third property, that alpha V and W is equal to alpha times the inner product of V and W. This one might actually be one that's not satisfied. Okay, because the reason being is that there's no restriction about alpha. If alpha is negative, we might be able to pull out a negative here and end up with a we know that the inner product here, we're going to have a positive inner product because of these absolute values. So we might be able to pull out a negative here. So let's try and create ourselves an example. So let's go V equals, let's say 1, 1, and W equals, well, I'll take W equals 1, 1 as well. And let's take alpha equals -2. Okay. So alpha times V and W, that inner product, is going to be the inner product of alpha V is -2, -2, with W, which is 1, 1. And based on this definition up here, we would have the absolute value of -2 times 1 plus the absolute value of -2 times 1. So this gives us 2, this gives us 2. We end up with 4 is our inner product. Now, alpha times the inner product of V and W is going to be -2 times the inner product of V and W. So 1, 1 with 1, 1. So this inner product is 1 times 1 plus absolute value of 1 times 1. And that whole thing gets multiplied by -2. That's a bit squishy. So that's -2 times 1 plus 1, which is 2. So that's -4. Okay, so the fact that this right side is always positive makes it difficult for property 3 to be satisfied anytime alpha is negative. All right. And so because we found a case where property 3 doesn't hold, this cannot be an inner product. Since property 3 isn't satisfied.